I'm Dr. S. Jayapurni, professor in EC Department of Sri Shanmuga College of Engineering and Technology. So today we are going to see about package level testing in VLSI. So before we go into this concept, why is this testing being done on VLSI? Testing is done on VLSI chips in order to make sure and to obtain that the final chip that we have obtained is working properly and the functionality is being tested. So this package level testing is performed after the die is assembled into the chip package. It ensures the electrical integrity, mechanical reliability, and thermal performance of the packaged IC. It is actually a last step before shipping the ICs to the customers. So just let us look into this diagram. So what is this? This level 1 is integration on chip. Level 2 is integration in package. The level 3 is integration on PCB. So it helps to identify the defects that appear during wire bonding, encapsulation, packaging, the stress solder ball attachment. So it helps to identify the error at the final step. So this package level testing, uh, it introduces new failure models whether the testing is necessary. It ensures high quality and reliability in final ICs. It avoids customer failures and it costly recalls. So what are the defects it identifies again? They are open or short circuits, bond wire defects, solder bump cracks, pad connection failures, and thermal issues due to packaging materials. So now let us look into this diagram. This is a tester power supply. This is a test head. The device interface bond is being given here. So the probe cord power supply plane is being given here. These are the pins. Inserted measurement point PCB is here. This is a multi-layer supply grid. Probe pad is here. Solder ball is here. This is the solder ball and here is the cut. So we can identify the by this method we can identify the defects. What are the various types of package level testing? The first is it is electrical test, mechanical test, thermal test. Under electrical test we have continuity test, leakage test, functional test, parametric test. Under mechanical test, we have drop test, bend test, pressure test. Under thermal test, we have thermal cycling, burn-in test, high temperature operating life. Electrical testing method. Continuity test. It verifies electrical connection between package pins and internal die. It detects open or short circuits. Functional test. It ensures package which performs all designed operations. It is performed using ATE. ATE is automatic test equipment. By making use of this equipment, it is a subsidy equipment that we make use of whenever we have to test a chip. Parametric test. It checks the voltage, current, timing parameters. It measures input-output leakage, threshold voltage, propagation delay. So these are the various types of test. Under mechanical reliability test, we have drop test. It determines IC's resistance to physical shock. Bend test ensures package can withstand PCB bending. Shear test. It measures the strength of the solder balls, especially in BGA packages. Wire bond pull test. It pulls bond wires to test bonding strength. So these are the various tests that is used to measure the reliability of our chip. It especially checks the strength of the PCB and strength of the chip. Thermal stress testing. Burn-in test. It operates IC at high temperature for hours. It detects early life failures, that is infant mortality. HTL, HTOL, it refers to the high temperature operating life, that is long duration test under elevated temperature and voltage. It ensures long-term reliability. Next is thermal cycling test. That is, it repeatedly changes temperature from low to high. Detect cracks in solder joints and package materials. So this is the diagram that tells us about the time and temperature and how this thermal stress testing is performed by giving the temperature chip in a brick, and in the chip the temperature is being increased for various time and its strength has been checked. So after why all these tests are being performed means the main applications are X-ray inspection, that is non-destructive test to inspect bond wires, solder bump voids. Acoustic microscopy, that is it detects internal cracks, delamination and moisture. BIST refers to the built-in self-test for packaged chips. That is, built-in self-test helps to check the crack, especially in memory faults, logic faults, scan chain integrity. Next, we have our boundary scan test, that is JTAG test, that is used for testing connections after soldering in printed circuit boards. So what are the common failures that we come across means that is pad lifting, bond wire breaking, package cracks, delamination, solder ball voids, electrical shocks or open circuiting, leakage due to moisture absorption, and thermal fatigue failures. So these are the common failures which is common in any VLSI chip, and that is why we go across these types of tests to make sure that there is no defect